We're now going to look at transformations of graphs. And to do this, what I've done is I've drawn originally the graph of y equals sine x on here. I'm going to look at some transformations on this. So first of all, we've got this one here where we've got y equals f of x plus k. So what that would be a translation by k in the y direction. So it means it would move it up, move every point on this original graph up by k units, whatever k was. So if I do the example of y equals f of x plus 2, so k in this case then is 2, then that would be, for this function, sine x plus 2. And it just means that every point on here would be moved vertically by 2 in the y direction. So this point here, which is at 1, would now add 2 onto it, and it would go to 3. This point here would add 2 on, it go to there. This point again would add 2 on, it will go to there. This point would add 2 on, it will go to there. It's currently at minus 1. We add 2 to it, it's going to go to plus 1. And if we add 2 onto this point here at 0 in the y coordinate, it would go to 2 in the y coordinate. And all the x coordinates would remain as they were. And an important line we could draw to help us draw this graph would be the center line or the horizontal axis for this one, and that's moved up by 2. So this new graph, this transformed graph, is actually symmetrical about this line. So the transformed shape would look like this. So that's our f of x plus 2. We've just moved everything up by 2 in the y direction. So if we now look at the next one, so this is y equals f of x plus k, where x plus k is inside the bracket. So that's important to note. X plus k is inside the bracket. And this is a translation by minus k in the x direction, so horizontally. So whatever k is, if k is 5, we're going to move minus 5. If k was minus 5, we're actually going to move positively. We're going to move plus 5. So it's whatever it is, it's the opposite sign. So an example for that, example for number 2, would be y equals f of x minus 30. So in our case, that would be sine of x minus 30. And so what that's going to do is it's going to take every point on our original graph and translate it by 30 in the horizontal axis. And we could show that as a vector. So it's translated by this vector, translated by 30, 0. So what that's telling me is all the x values are adding 30 on them, but all the y values are staying as they are. So that means that this point here would move by 30, so that would go to there. This point, so that would now be 30 degrees. This point, which was at 90 as an x-coordinate, would move again by another 30, so that would actually be 120. This point, which is 180, we add 30 on, it's now going to be 210. This point, which was 270, is now going to be 300. And this point, which was 360, is now going to be 390. So it's going to look like this. And actually, if we consider that the original graph would have carried on into the negative portion like that, then our translated graph is also going to follow that same shape. So this point, wherever that was, would have moved by 30 to the right to give me this point. We're now going to look at the transformation which is given by y equals k times f of x, where k is a number. And so what that would be a scale factor k in the y direction. So that means it would be basically a stretch in the vertical direction. So an example of that could be if I wanted to draw the graph of, say, 2 times f of x, which in this case, since f of x is sine x, it will be 2 sine x. And that's simply going to have the effect of doubling the amplitude for this graph. So rather than it going through 1 here, 90, 1 is this point. That point there being 90, 1. It's now going to be doubled in the y direction. So the 90 will stay the same because that's the x direction. But the 1 is going to be doubled, so it's going to go through at this point. And then here, since that was 0 as the y coordinate, that's going to remain the same because 2 times 0 is 0. This point here was -1, and if I double that, we'll get to -2. This point again is 0, so that's going to remain the same because for double 0 still stays 0, as does this point here. So if I sketch that, then what I'll get is a graph that's basically been stretched in the y direction. If we now look at the fourth one on the list, so this is y equals f of, and then this time the k is multiplying the x inside the brackets, what that has is an effect of squashing the graph in the x direction. So in other words, it's a scale factor of 1 over k, which means the larger the value of k, the more the graph is compressed in the x direction. So an example of that could be if I wanted to sketch the function y equals f of 2 times x. So in our case, that would be sine of 2x. So I'm going to again draw this on the same graph. And so because this is going to be a scale factor of 1 over k in the x direction, and k is 2, that means we're halving every x coordinate. So here, every x coordinate is halved, but the y coordinates will remain the same. So we can take this point here, and what we're going to do is we're going to half it. So the x coordinate was 90, it's now going to be 45. This point was 180, it's now going to be 90, the y coordinate remaining the same. This point was 270, it's now going to be 135. And this point 360 is now going to be 180. So if I join those up, what I would get is this. And if I continue in the same way, then we can see that actually it's as though it's the original graph drawn in red there, but it's been squashed in the x direction. And that has had the effect of doubling the frequency of this sine graph. Looking at the fifth one on the list here, then we've now got y equals minus f of x. So because our original function was y equals f of x, where f of x was sine x, if we wanted to draw this, if we wanted to look at this one, it would be y is minus f of x, and in our case that would be minus sine x. And as we can see, it says this is a reflection in the x-axis. So it's just going to be flipped around the x-axis here. So whatever points I've got, so like this point here, is now going to be reflected in the horizontal axis. So this one's going to end up there. The ones that are 0 are still going to remain 0. And this one, at -1, is going to end up at +1. So the reflection is going to look like this. Now if we look at the graph of where we're doing a transformation, which is y equals f of -x, so y equals f of -x, then in our case that would be sine of -x, and all that is a reflection in the vertical axis, so a reflection in the y-axis. So any point that I've got, for example here, is just going to be reflected in the y-axis, so it's going to flip over. So this point now is going to go to here, and we've got at this point it's going to stay where it is. Obviously that point will be reflected to there, so we're not going to see any difference. But this point here is going to be reflected to there. So this new graph would look like this. A reflection in the vertical axis.